Hey guys, it's Mrs. Dugan. So today we are going to be learning about conductors and insulators. What you need to have out in front of you right now is what's on my screen. You should have glued this in yesterday during class, except first period. First period, you, my friends, need to make sure that you have this from the sub. Okay. If you were absent yesterday, please ask the sub for this paper. It's in my sub folder, so if you need it, go up right now. Don't be a dingus and just sit there through the video and not get your notes, okay? As a reminder, our test is not next Wednesday. It is the 28th, okay? So it's coming up quickly. I need you to get these notes. We need to start practicing so that when we hit the end of school, you will be a superstar when it comes to thermal energy. All right, let's go ahead and get started. I'm gonna pull up my PowerPoint. I gotta say, first of all, I'm super excited because my husband, Mr. Dugan, let me use his super cool setup. I've got this clickety-clack, oh no, this isn't right. Oh. See if this works. No, that is not right. Sorry guys, we're gonna figure this out. I don't want it to display settings. There we go. Let me see if that worked. Yeah, it worked. Okay, so heat transfer. Anyway, so I've got a clickety-clack keyboard right now, and it's not even, it's so much louder than my one at school, and it's super satisfying. So, and not only that, but it lights up even cooler than mine does. Anyway, okay, so heat transfer. We've talked about heat transfer a little bit so far, and what we need to know is that heat transfer is going to be the transfer of heat from one object to another. I forgot to mention this, but if it is in red, except for the definition of heat transfer, you need to write it down. All right, it's one of those where you write down that part and you get to listen to me talk. So heat transfer is the transfer of heat from one object or one area to another. Remember, all thermal energy goes from places of high energy to places of low energy. So again, I talked about if I had an ice cube in my hand, the heat from my hand is going to go into the ice cube to cause it to melt. Now we have those three types of heat transfer. That is conduction, radiation, and convection. And just a brief thing, you're looking over here at this screen. If I can find my mouse. Oh, still can't find it. Nope. Oh, there it is. Okay, so if we look at this pot here, we've got radiation coming out from the pot. So if you put your hands next to the pot, you can feel that heat. We've got convection going within the pot because this water, this liquid, is boiling. We also have some convection right here with the steam, and then we've got conduction. So if you touch the pot, it's going to hurt because that heat transfer is happening. The heat is coming from the pot into your hands, and then you burn yourself and have to go to the hospital. All right, so when we talk about heat transfer, we're going to start talking about minimizing heat transfer and maximizing heat transfer. When we think of minimize, if we think of just the word minimize, minimize means to get smaller. Maximize means that we're going to get larger. So when we maximize heat transfer, that means that we want heat to go somewhere. When a space heater is a great example. What are space heaters also made of? Metal, okay? So metal is a great way to maximize heat transfer. Cookie sheets. If we're baking cookies, we don't want to put it on something that's not going to cook the cookie sheets. We want that conduction to happen. Guess what it's made of? Metal. All right, and then we also, let's think about our turtles right there. Okay, I told you that one way that we made sure those turtles stayed alive over the winter was I bought a aquarium heater. That is also going to maximize or move a lot of heat. Now, minimizing means we don't want heat. You don't want to reach into the oven and burn your hands because you're using a conductor. You want something to keep heat in or keep heat out. So think about these, like the plastic handle on the pot. The reason why we have that plastic handle is so it doesn't get hot. Our hands don't burn every single time we touch a pot. all right? We use oven mitts so that we keep the heat out where we don't have it. Now, I'll tell you the other day, I have a pair of oven mitts that I've been using since, I don't know, probably 2018. And they're getting really thin. So when I went to put my hand on the hot pot, what happened is my hand burned because I didn't have anything to keep the heat out. A way to keep the heat in is our winter coats. Our winter coats are going to minimize heat transfer. It's keeping all of our body heat inside the coat so that we don't get cold. So again, maximizing heat transfer, maximize, we want heat transfer. Minimize, we don't want heat transfer. We don't want the heat to either get in or get out. So when we want heat to get out, when we want for it to transfer, we're going to use what's called conductors. And these are used to share thermal energy and make it move easier, okay? So again, we're using metal to cook. We're using metal in our, for example, in our heating units. You're gonna see copper, you're gonna see all of these metals because they allow for heat to transfer very quickly, all right? If I put a metal spoon onto a cookie sheet or on my pan, that metal spoon is gonna get hot because it's conducting, it's sharing that thermal energy and it's allowing it to get hot. Now, when we have materials that are good at conducting this heat or moving the heat, it's because their particles are really close together. So think about it. If you remember the game of telephone, so would it be easier to spread gossip if a lot of people are close together or if they're really far away? All right. So conductors are super big gossipers. They are going to share that information, share that heat along the line. And it's usually a solid. So we looked at it in our thermal energy simulation. That solid, those particles are really close together. They have a lot of potential energy and they're shaking like this and they're really close. They're bumping elbows. So they're going to be able to share share heat much easier than something like a gas where the particles are flying everywhere and they're not actually going to touch very often. So again, as I've said, metals are great conductors. That is why you use metal pans. That's why, I lost my train of thought. I'm really only thinking about cooking right now. But there's, in cars, that's why some engines are made of metal, but we have some insulators and we'll get into that too. All right, but we want to move thermal energy. We want to move the heat around. That's when we use a conductor. Again, conductors are going to maximize heat transfer. They share the heat easily, and those, we know metals are really good conductors. That's really a big one, is the metal things. So curling irons, if you curl your hair, you're also using conduction because it's a direct contact, okay? If you're curling your hair, your hair is making direct contact with the metal of the curling iron. Skillets, again, just think cooking. All of that is going to be big. All of those kind of instruments are good conductors if you're trying to cook food. Now, you don't want your hand to burn as you're cooking. So that's why we are going to start using insulators too. Insulators are going to trap the heat. They're like, no man, you're not leaving, okay? You have to stay here. So if you think about what are some things around your house that you use to make sure that you don't get burned? Oven mitts, all right? Maybe you use a wooden spoon to cook, or your parents use a wooden spoon. Maybe use a plastic spatula. That stuff melts, yes, but it's not going to conduct heat. It's not going to burn you as you use it. So again, we are going to use these to keep heat in or keep them out. Now, we all know that Stanley and Awala and Hydro Flask are big names in the water bottle company. Why is that? Well, it's because they are using insulators, great insulators, to keep drinks cold. The way that they're doing that is that they're going to minimize the heat transfer. It's going to keep it in. Heat can't get in those things. I can tell you with my Stanley at times and my Hydro Flask, I can leave it in my car when it's not 100, but when it's not 70 degrees, 80 degrees, and when I come back from school after being in there at 4 a.m., there's still ice in it. How the heck did that happen? This car is hot. I walk in and I burn my butt on my black leather seats. How is my ice still ice and it hasn't melted? Well, it's because those cups are made from insulators. So, examples of insulators are feathers, wood, wool, plastic, and there's a bunch of other stuff. So think about things like what in your house helps you not get burned. Again, insulators are going to minimize heat transfer and they trap heat. Examples that we can think of. If you are cold, what do? You put on a coat. That coat is going to have insulation. You're also going to have insulation in your house. This is why your house doesn't drop below 50 degrees if you have your, if your power goes out. It's not going to get dropped down very, very low. It's really important that we have good insulation in our houses, because if we don't, then we're going to freeze. But if you do have good insulation, it can remain at a decent temperature. Not great. It's not like a sauna or anything. But the better insulation you have, the more likely it'll minimize your heat transfer. So ultimately what's going to happen, this is it for the notes, okay? But what I need you to understand is that conductors maximize heat transfer, okay? So let's do some hand motions, okay? I'm going to quiz everybody. Conductors maximize heat transfer. Conductors maximize heat transfers. Insulators minimize heat transfer. Insulators minimize heat transfer. Okay? Those are the two big ideas that I need you to understand by the end. If you did not get anything written down, you probably should have. But if you did not, go back through the video at 2-speed, whatever, get your stuff written down, and go ahead and get on to the insulator and conductor sort. That is for a grade. Yes, you have to do it. If it's not in by 9 a.m. on Monday, you get a 0. All right, guys, have a great night, great day, and I will see you.